Like roller coasters, pendulum rides build on the interplay between potential and kinetic energy, as the potential energy in the high points is converted to kinetic energy at lower points. The swing moves faster and faster until it reaches the bottom, and then slower again until the turning point. Playground swings let us experience this interplay at an early age, feeling light at the turning points and heavier at the bottom, as can be illustrated with a slinky taken along. Sometimes you can find a longer swing from a tree in a park, and note that longer swings give longer periods. Even longer swings can be found in amusement parks, and they can also reach larger angles. The force in the lowest point depends on the maximum angle. If you swing up to 90 degrees, you would feel 3 times as heavy as normal in the lowest point, 3G for short. Amusement ride swings can go higher than 90 degrees. At the highest point, the ride constraint system then needs to push on your shoulders, which is what are referred to as negative Gs. Coming down, moving faster and faster, the swing needs to provide the force required to keep the motion along the circular path. Since this ride swings higher than 90 degrees, we expect the maximum force on the rider to be more than 3 Gs. This agrees with accelerometer data. This giant gyro swing reaches 120 degrees, and we would expect the force to reach 4G. However, the data show even stronger forces, and they also depend on the position in the ride. To understand the differences, we need to look closer at what happens as the circle with 40 riders rotates, while the pendulum swings back and forth. The riders move in the rotating coordinate system of the pendulum itself. This leads to a Coriolis effect, which is about half a G in this case, and depends on the direction of the motion relative to the horizontal rotation axis of the pendulum. Coriolis studied forces on machine parts moving in a rotating system. In the giant gyro swing, you are a moving part experiencing forces, as the whole plane of the circle also rotates due to the pendulum motion. If you know what to look for during a ride, you can feel how the force at the bottom depends on which way you move. The math is worked out in more detail in our paper.